Pet Life Radio.
This is Pet Life Radio. Let's talk pets.
Good day from California. Welcome to the Anything Possible podcast. My name is Dr. Courtney. I'm a veterinary surgeon, former co-host of Pet Talk on Nat Geo Wild, host of the Dr. Courtney Show, and just all-around pet lover. As many of you know, this podcast where we celebrate the fact that everywhere you look, there's the beauty of the human-animal bond. And that bond influences our everyday lives. And lucky for me, I get to talk to some of the most fascinating and engaging people that help to explore and strengthen that human-animal bond. For better or worse, what does that phrase make you think of? For better or worse? I'm sure for some of us, we think of marriage, and that makes sense because those words, a lot of couples include in their wedding vows, and it's usually followed by till death do us part, right? Well, it turns out that that phrase, for better or worse, has a lot to do with today's topic. When I was ruminating about this subject, I immediately started to reminisce about a time where I got into a little bit of trouble with a newlywed couple. I was a young veterinarian. I was practicing in Los Angeles, and on that long, circuitous journey of becoming a surgeon, doing multiple internships, a residency, and all the rest. And, occasionally I'd work emergency shifts to try and make ends meet. Well, one night I met this lovely newlywed couple who presented with this young, happy-go-lucky, and hilariously sarcastic black lab puppy named Fossil. Fossil had been recently welcomed to the family as part of the marriage celebration, and just welcoming a new dog into their home. One day, the young couple came home to discover that Fossil had had multiple episodes of just the grossest gelatinous diarrhea on their living room carpet. I mean, as you can imagine, they were not happy about it. The young lady was especially miffed because she was still, shall we say, warming up to the idea of having a new puppy in the house. And as part of the diagnostics and treatment, I submitted a fecal analysis and prescribed an antimicrobial to help Fossil with his diarrhea. I told him that the results wouldn't be available for a few days. But when they came in, I called the pet parents multiple times and I didn't get a call back. Thinking they were busy, like we all are, I decided to leave a message on their voicemail. I said, "Hi, this is Dr. Courtney. I just wanted to let you know that Fossil's fecal results are in. He did test positive for Giardia on PCR, and the lab actually saw Giardia trophozoites in the sample under microscopic analysis, or essentially they saw it and it tested positive on PCR." And at the end of the message, after I gave him a little brief information on Giardia, I said, "And don't forget, Giardia can also be transmitted to humans, so just make sure you wash your hands and clean up after Fossil, when he's around the house and when he goes to the bathroom." When the husband came in to pick up the new medication I had prescribed for Fossil, he was upset. I mean, really, really mad. We eventually had a face-to-face. He said, "How dare you leave a message on my voicemail saying that humans can get Giardia as well? Now my wife is concerned. It's created a real boatload of friction in the house." So I obviously had some explaining to do. And after a long discussion, he was comfortable that as long as he practiced some common sense cleaning and disinfection practices, the risk for transmission of Giardia would be pretty low. Because of that situation, their for better or worse almost took a turn for the worse. But it also made me realize that our relationship with pets and wildlife is similar to a marriage. Like a marriage, there's a special link or a spark between us. We both count on each other, we rely on each other, and for the most part, we should enjoy each other. But perhaps there's one marriage quality that is near the top of the list, if not at the top of the list, and that is mutual respect. There are probably people who think I shouldn't be using the word respect when it comes to the group of organisms that we're going to talk about today, but I will. I'll use it. I think we should have a healthy respect for pathogens. And pathogens are any microorganism that can cause disease. These include viruses, bacteria, fungi, parasites, and prions. And today I have the pleasure of talking to one of the leading experts when it comes to pathogens. He's going to talk to us about how we are inextricably linked and bonded to these pathogens, for better or worse. We're bonded to them directly, but we're also connected to them through our pets and via wildlife. And we'll discuss why pathogens warrant our continued study. To underscore just how broad and extensive that intersectionality between us, animals, and the environment and pathogens are, We're going to touch on a variety of species, including primates, fish, birds, and other species. And just to give you a heads up, we're going to be using terms like zoonotic, zoonosis, reverse zoonosis, pathobiology. So keep your dictionaries nearby. No, I'm kidding. We'll do the best to define those terms as we go along, but there's a ton to cover. So this will be a very fast-moving conversation going across a variety of species. But before we get to our exciting guest, I want to be sure to let everyone out there know how to get in contact with me. If you have questions, thoughts, or topic discussions, you can reach me at Dr. Courtney DVM on Twitter or Instagram. Questions with positivity and love will get answered with priority, but not exclusivity. So we'll pretty much answer anything. So now that we've set the scene, let's pause for a few brief moments. And when we come back, we'll be speaking with a truly illustrious guest in the world of infectious disease.
DINOVITE.com.
When we put him on the Dynovite, he took right to it. All of these symptoms disappeared.
Dynovite is nutrition.
If you want the dog to be healthy, you got to feed it something healthy.
Something that he actually likes to eat. You need to put him on Dynovite.
Dynovite for life.
If you love your dog, you don't just want him healthy, you want him to be happy.
You won't believe how happy your dog will be.
DINOVITE.com.
Let's Talk Pets on PetLifeRadio.com.
And we're back. I'm super excited about the discussion we're going to have today. People use the term passion project, and I'm not sure if there's a term called passion interest. If not, I'm inventing that term right now. Besides veterinary surgery, studying infectious disease is one of my passion interests. I'm extremely interested in it, and I'm super passionate about it. So I'm kind of geeking out a little bit right now because our guest today is Dr. Tony Goldberg. Dr. Tony Goldberg is a veterinary epidemiologist, the Associate Director of Research at the Global Health Institute. He's a professor of epidemiology at the University of Wisconsin-Madison. He is a rigorous researcher and a megastar in the world of infectious disease. His resume is impressive and long, but the core of his studies is understanding how pathogens cause infections in dynamic ecosystems with many moving parts. Essentially, he studies how pathogens cause disease and the pathways in which these bugs cause the infections in real life. He catches emerging diseases in the early stages so that we can contain them. Essentially, he makes us a lot safer. So let's welcome to the podcast. Welcome, Dr. Tony Goldberg. I appreciate you joining us today.
You're very welcome, Courtney. Thanks a lot for having me.
Oh, excellent. Now, we'd like to do something on this podcast called Set the Scene. Could you do us a favor? Set the scene of young Dr. Goldberg when he first developed his love for animals and how that led into veterinary medicine.
Yeah, you bet. Well, I should say that what I do is sort of a pathogen passion project.
Yes.
Yeah. So young Dr. Goldberg, I guess that would be after I got my veterinary degree. So
okay, we could start before that. Let's start pre-doctor. And when you're young and you're, growing up, I'm not sure if you grew up in the Pacific Northwest.
I did not. I grew up on the East Coast in Connecticut.
Oh, wow. We're both from Connecticut. This is amazing. I actually, in full disclosure, we didn't plan this. I had no idea you were actually from Connecticut. I'm from a small town called Burlington. Where are you from, Dr. Goldberg?
I am from Stamford, Connecticut. So on the other end of the state, but I know Burlington really well.
When you're from Connecticut, man, it's pretty easy to know all the towns in the state. It's pretty small. So that's fascinating. So you're in Stamford, and how did you develop a love for animals?
So there's a couple of formative experiences. I think you'd agree that most of us veterinarians have been influenced by someone or something early in our lives. For me, it was a couple of things. It was where I lived. I lived in a house in the suburbs, and my folks kind of kicked me out of the house early in the morning and said, go play, and I would come back in the afternoon. So that was
my upbringing, exactly the same.
There you go. So and that was before people were so concerned about emerging diseases like Lyme disease. So I just went out to the woods and I played around. I turned over rocks. I went wading in the local stream. I turned over rocks there. I looked under logs. So kind of what I do now is turning over rocks, but with fancy tools in the laboratory. I'm kind of looking to see what's out in nature. So I developed a love for natural history and for nature early on. And then When I was in junior high, I volunteered at the local nature center where they had it was kind of a small zoo and petting zoo and museum. And I would go there and I just loved taking care of the raccoons and the otters and the sheep and the goats and the pigs. So I developed this love for all animals, and that kind of followed me throughout my life.
That's fascinating. I love how you painted that picture of literally my life growing up. It's just going out, that was our version of entertainment, literally go outside. And sometimes that involved, errands around the yard and yard work, but that was part of the natural experience. And then, so you developed that love for animals. And then how did you transmute that into becoming a veterinarian and then ultimately veterinary epidemiology?
So my route to the career of veterinary medicine was a little bit indirect. It wasn't the typical one. I started out getting my PhD before I went to veterinary school. Yeah, so I kind of thought some of my role models were in college were professors of mine and scientists elsewhere who studied animal behavior. So I was really jazzed to be sort of an animal behavior expert, and I loved primates. So I kind of envisioned myself as being sort of following in the footsteps of Jane Goodall or Diane Fossey or somebody who was really passionate about wild primates. So I went to graduate school and I studied primates, actually with a student of Jane Goodall, and I studied chimpanzees, and I just loved it. But that was in the 1990s. And right when I was studying chimps, it was discovered that the AIDS virus came from chimps a long time ago and was transmitted to humans. And that was a wake-up call for everyone in the field of primatology and infectious disease. So I got kind of sucked into that because I was studying chimps right at the time when that discovery was made. And I said, wow, this would be a really interesting career angle. So I went to veterinary school after that so I could learn more about animal disease and combine my passion with wildlife and animal behavior with this really keen interest in the idea that humans and animals are linked by pathogens.
And that is fascinating because that essentially is what we celebrate. At least I try to celebrate every chance I get, is that human animal bond. And that's exactly what we're doing today and during this conversation. So I'm so happy that you're joining us because that is the basis and the foundation through which I see a lot of the world and through which I see the lens of pathogens. And it's interesting enough to know that it's that human animal bond that actually stimulated you or kind of provided that spark to go to veterinary school. And that, yes, you're going to school for the study of animals, but it was actually the discovery of a human disease, AIDS, that stimulated that passion. And that's a fascinating thing, which leads me into this. I get tons of questions from the media about what diseases can you get from your dog? Essentially, zoonotic diseases. And I'm not sure why I get that question. It potentially is just the kind of the irony of how close we are and how much we love animals and that idea that potentially is there a lurking or hidden danger. But there is not a commensurate interest in diseases that we can give them. Essentially, there's an interest in when dog bites man, but not when man bites dog. And so your findings in chimpanzees, and your study and your research have been truly fascinating, mainly due to the concept of reverse zoonosis. And I've heard the term anthropogenic also used. I noticed that you prefer the term reverse zoonosis. Can you define for us what actually is reverse zoonosis and what was the kind of the seminal moment? And I'm guessing it was those outbreaks in 2013 and 2017, but what was the seminal moment that you really started to delve deep into the concept of reverse zoonosis?
Yeah, great questions. You're absolutely right. So I'm sure most of your listeners are aware of the term of zoonosis, which is...
Well, just in case, let's define that.
Yeah, you bet. So a zoonotic disease is a disease that an animal gives to a person. And so in your intro, you talked about poor Fossil. I can commiserate. I've had Giardia on a couple of times and it ain't pretty.
Oh no.
So
that's horrible.
I totally feel for Fossil and Fossil's owners. But we think a lot about diseases that affect us and come from animals. Like, for example, West Nile virus, Ebola, Lyme disease, some of the big infections that we're worried about on a global scale. Those are the ones that come from animals today. And then, of course, there's the ones that came from animals recently, like HIV/AIDS, maybe a few centuries ago, came from chimps. Or, there's estimates that most human infectious diseases at some point came from animals.
Got it.
So people are really aware of that because, hey, we're humans. So we care about ourselves, and that's understandable. And we have a massive global public health system that focuses on the health of humans. But we pay a lot less attention to reverse zoonoses or anthroponoses. And, those are not great terms because they're a little bulky because we don't focus as much on them. What they are, they're diseases that we can give to animals. So, pathogen transmission is a two-way street. We can give stuff to animals and they can give stuff to us, and the pathogens don't really care which direction they go in. We just pay a lot more attention to the zoonotic diseases because we're humans and we care about our own health. But if you really look at it, reverse zoonotic diseases that we transmit to animals, are a global problem that is seriously neglected. As veterinarians, we understand it, but it doesn't make the news nearly as often as the other way around.
Right, for sure. It really doesn't. And the challenge is, because it's so neglected, I think that we need examples of what is possible out there in terms of the things that we can spread. There are, at least in the companion animal or small animal veterinary world, we talk a little bit about things like E. coli and other organisms, other pathogens, but you actually were studying that term, reverse zoonosis or anthroponoses, in chimps. What did you discover in terms of those outbreaks?
Yeah, so I've been aware for many years since my veterinary training that reverse zoonoses do occur. I think from the companion animal side, you'll be familiar with this one. One of the ways that we can be pretty sure we have influenza is if our pet ferrets get sick. So, ferrets are pretty susceptible to influenza. So if you're coughing and sneezing and suddenly your ferret is coughing and sneezing, you probably gave flu to your ferret.
Unbelievable. Fantastic. I did not know that.
No, okay. Well, that's an example of a common reverse zoonosis that happens in people's homes. But so I knew about this, but honestly, it didn't really hit home till 2013 when I was in Africa in a field site in Uganda, Kibale National Park. And this is a famous field site for chimpanzees. They've been studied for 40 years. Every individual is known. They're used to humans. You can follow them all day long. And they started to get really sick. They started to cough and sneeze and have fevers, and it was kind of mayhem. We were really worried, and it was scary. So at the end of this outbreak of respiratory disease, we lost 10% of the chimps in the population.
Oh my goodness.
Yeah, it was really upsetting. And these weren't like just nameless animals. So we lost animals that I had known for my whole career. Like the first chimp I ever saw in the wild, this big bruiser male named Stout. He charged me, actually, one of the first times I saw chimps back in the 1990s. And I mean, I didn't have a personal relationship with him, but I certainly knew who he was. And he was kind of a big player in the community. He died. And it was much more than just, a conservation issue. It was personal.
And I don't want you to lose your train of thought. I apologize.
Yeah.
But describe for me, obviously, when we're around dogs and cats and small animals, and you just mentioned ferrets, we get that idea. But what is it like, that just the raw imagery of it, watching chimps be ill? What are you seeing? Paint a picture for us. What are you seeing when you're watching chimps get ill? Are they at the bottom of the forest floor? Are they coughing? Are they sneezing? Are they off to themselves? What are you seeing out there?
Yeah, well, a normal day in the forest with chimps is pretty exciting. Right. They run around, they beat up on each other all the time. There's fights, they hunt monkeys, they're traveling really fast through the forest. And it's kind of like Daniel Day-Lewis and Last of the Mohicans. You just got to hightail it through the forest to keep up with these animals. But on this day, they were nothing like their normal selves. They were lying on the forest floor, kind of with their heads in their arms, looking off into the distance, coughing and sneezing and having runny noses, and clearly just miserable. And they weren't eating, and so it was clear something bad was going on. So it was really obviously not normal. If they had been humans, and it's hard to see them as anything but very similar to humans, you would look at them and say, wow, that person needs to get to a hospital.
Got it.
So it was not a subtle thing. So obviously we were really concerned. We didn't know what it was. And that was scary too, because it could have been a zoonosis. For all we knew, they had Ebola or something. So we were scared. But the epidemic subsided, and the sick ones got better. Unfortunately, those 10% died, and we started to investigate. So we had collected fecal samples from them during the epidemic. And it's kind of magic these days, but you can detect a lot of pathogens in fecal samples, especially if you think about respiratory pathogens. If you're sneezing and coughing, you swallow it and it goes through you so you can get it at the other end. So we did that, and I worked with pediatricians here at University of Wisconsin-Madison. We're lucky. We're one of the few vet schools that's just down the street from the major medical school of the university system. So we have a great department of pediatrics, and they helped us diagnose this the way they would a snotty kid who comes into the clinic. And it turned out to be a virus that had never before been found in chimps, human rhinovirus C. And yeah, and we know a lot about this virus. It's a human sniffles virus, so it's one of the most common causes of the common cold worldwide. It circulates in kids. It's usually no big deal, except if the child has asthma. If a kid with asthma gets rhinovirus C, they can get really, really sick and have to be hospitalized.
Wow. And sorry to interrupt you,
Yeah.
but just like you did when you were describing your upbringing, now it almost sounds like you're talking directly to me. And of course, I know that there's people listening who also have asthma, but I have asthma. And what I would describe to people is if I get a cold, then my cardiovascular endurance is almost as if I was, breathing through a straw. I mean, it is so severe. Partly because I have, hyperconstrictive, hypersecretion, bronchoconstriction with the asthma, and then you couple that with the common cold. And so it's something that I think people listening right now have tremendous personal experience with. And so I'm certainly glad that you brought this to our attention. Essentially, chimps are catching the human version of the common cold.
That's right. And have you ever done 23andMe or any one of these services?
No, I haven't, but some of my relatives have, so I need to get on it.
So it turns out that a lot of people like you with asthma have a particular gene. It's a variant of a gene that makes us susceptible to asthma and susceptible to rhinovirus C, along with other pathogens. The technical term is the CD163 receptor gene.
CD163 receptor gene. Okay, this is my weekend homework. Got it.
If I get just one sec.
No problem. This is important.
Yeah, and my colleagues will kill me.
It is one of those things where you look at it and you notice that they're coupled. Essentially, if you have asthma and you get the common cold, I think the point that you're really trying to underscore here is that it's not a coincidence. You know what I mean? And that I think is really important to know. And if you're armed with that knowledge, then potentially there are preventative strategies that you can employ if you say, hey, I've got asthma, so I need to be particularly diligent about catching the common cold.
Okay, so that's exactly right. So the elite. So if you've done 23andMe, you might have been assessed for the CDHR3 allele.
CDHR3. All right.
So CDHR3, it's a protein on the surface of your respiratory epithelial cells that does something good, but the virus attaches to it. And if you have the version of this gene that predisposes you to asthma, the virus really attaches to it. And it can make you a lot sicker. So, yeah, you're totally right. What you described is common for people who have asthma and get a cold. They get really sick. So we took a look at the chimps of Kibale National Park and actually all chimps across Africa using published genomes, and we did some genotyping ourselves. And they all have the version of this CDHR3 gene that makes people really susceptible to rhinovirus and asthma. So the story here, there's two things. The kind of reverse zoonotic story is that every chimp alive is like a person with asthma. They've got this gene that predisposes them to severe respiratory infections with rhinovirus C and probably other human pathogens. And the reason why some people have this gene and some people don't is that we probably evolved to deal with pathogens like rhinovirus C when we started living in big cities and stuff like that thousands of years ago, but chimps haven't. So chimps are universally genetically susceptible to infection by rhinovirus C. And when they get it, it hits them like a kid with asthma.
Unbelievable. That's really powerful stuff. One thing I wanted to ask you about is that even on the companion animal side, we have a lot of contact and connection to some of the pathogens that you experience too. One of the power of your work is the connections you make between species and animals. And for instance, many veterinarians and pet parents listening right now may have had an encounter with parainfluenza. In fact, many believe it's the most common viral pathogen responsible for co-infections in cases of canine respiratory disease complex, or basically canine cough. Essentially, Bordetella and parainfluenza, as you know, that can act as teammates on the same sort of evil team to infect the dog's lungs. And in humans, parainfluenza is a common cause of croup, or that cough, that whooping cough. Have you recently encountered and studied parainfluenza in primates? And did you find that parainfluenza had any bearing in the outbreak in 2017 and 2018?
Yes, we did. So this outbreak of respiratory disease in chimps happened again in 2017.
Okay.
And in fact, there were 2 outbreaks in 2 nearby chimp communities, and I was there for those. It was the same deal. Chimps were getting really sick. There was 10% mortality in one of the communities. They looked horrible. You felt terrible for them. And we repeated our pathogen hunting exercise, and we found parainfluenza virus 3 as the cause of the outbreak in one of the communities of chimps. Not in both, but in one. So
what was the cause of the other outbreak?
So the cause of the other outbreak was yet a third human pediatric respiratory disease virus called metapneumovirus, another very common global cause of the sniffles in kids, but it's more severe than parainfluenza. So we saw one community of chimps getting mildly sick, and they had parainfluenza, another community of chimps getting really sick and having 10% of them die, and they had metapneumovirus. So now in this one population of chimps, we found 3 separate viruses on 3 separate occasions that had somehow gotten into the chimps and caused really severe disease. And all 3 of those viruses were sort of common human sniffles viruses of kindergarten age children.
Interesting. So you rhinovirus C 2013, then parainfluenza, then metapneumovirus, and all of these you mentioned have somehow gotten into the chimp population. I want to talk to you about the somehow got in there, but what I think is most interesting, and I want to know if you agree with this, is that these are pathogens, as you say, that would cause very mild changes or mild signs in the human population, just some sniffles. But in chimps, they could be absolutely deadly. So reverse zoonosis or anthraponosis, this is not a term to be used casually. These can actually cause real life consequences and death in other species. Would you say that's basically true?
I would say that's definitely true. Yeah. In chimps, reverse zoonoses are of this type, including some of these viruses, have been documented across sub-Saharan Africa. So this is happening all over, and it's killing apes, gorillas too, by the way, across sub-Saharan Africa. So it's not surprising. We are great apes. That's the kind of animal that humans are. So It makes sense that we can share pathogens with great apes. But you're right. If you think about it, we're kind of tough apes from a disease perspective. We live in really crowded situations. I mean, no chimp could live very well in an apartment building in New York City. It's too crowded.
I'm sure many have tried, but they cannot live in an apartment in New York City.
Well, the rent's too high.
There you go. There's no way they could work that hard. Yeah.
That's right. So these chimps have never come in contact with pathogens that have evolved in humans to deal with our crowded living situations. And we've adapted. We have gone through a process of natural selection where we can tolerate some of these nasty pathogens. We're kind of in an arms race with these pathogens. They try to make us sicker. We fight it off. And we've achieved a happy balance in a sense, while still living in our crowded communities. But when these pathogens get out of humans and go to our nearest relatives who've never lived in cities, live in sparse communities and forests with very little interchange between the communities, these pathogens are like a wildfire. They go through unchecked because the animals don't have the genetic barrier to prevent them from spreading.
Well, you've really did an excellent job of highlighting some of the factors responsible for the spread and the speed of pathogen transmission among the chimps. But let's take a step back for a second. How do they enter in the first place? Are there factors, environmental factors that cause the pathogens to actually enter the population? And then you just clearly identified some factors that cause it to sort of go on hyperdrive and spread really fast.
Yeah, so that question, how do these pathogens enter the chimps, is sort of the 800-pound gorilla in the room, if you will.
Right. To use a very apt analogy, that's excellent.
There you go. So it's that's the big question. So the story is pretty clear. Virtually any of these common cold human pathogens, viruses and bacteria, can infect chimps. I think that's a safe assumption. But how do they get there? this is where there's a lot of debate. There's actually guidelines published by the International Union on the Conservation of Nature that describe how to interact with chimps in the wild in a way that will reduce the risk of reverse zoonotic transmission. And people are aware of these guidelines, but unfortunately, chimps are still getting sick. So the two big ways, sort of big category ways this could happen is either people carrying these pathogens enter the forest and give them to the chimps in the forest, or chimps come out of the forest to interact with people and human settlements and get them outside of the forest. And either one of those is possible.
Either one is possible. In your research and in your intuition and gut, what do you think is more likely possible between those two scenarios?
That's a good question. And this is going to sound like a cop-out scientific answer, but I think both, depending on the community of chimps. So one of the communities we studied in Kibale National Park is sort of in the center of the forest. It doesn't interact with villages. It just stays in the middle of the forest. So its only contact with people would be people entering the forest. So in that community, I think the likeliest way that these pathogens are getting in is by people carrying them into the forest, sneezing on a leaf, wiping their hand on their nose and touching a stick, something like that. And those people would be scientists like myself, or field assistants, trail cutters, foresters, people coming in to harvest forest products. There's a slew of people who go into the forest for various purposes. But in the other community of chimps in Kibale National Park that we studied, they're at the edge of the forest, and they go out all the time to raid crops and go into farm fields. And you could easily imagine them kind of passing through a village and, touching somebody's dirty laundry, or drinking out of a puddle that the kid has been playing in, or, being in the farm field, raiding bananas where somebody has set up a camp. So I think at the end of the day, when we get to the bottom of this, and we're going to find that there's situations where both things happen.
Got it. That is definitely not a cop-out answer. I think it highlights the fact that pathogen transmission and pathways are complex. We know that they're very complex. And not to be gross, but all of us are adults here listening. Is there any potential for those who go into the woods and, let's say, they're working in the woods, they obviously don't have, very advanced in the woods sort of facilities and toiletries. Is there potential for chimps to have human chimpanzee fecal oral transmission of some of these pathogens? Because you just mentioned, looking at fecal samples is a great way to kind of do some virus detection. Do you think that that's possible among chimpanzees?
That's very possible. Yeah,
okay.
So the respiratory viruses are pretty bad, but there are other parasitic pathogens. You mentioned Giardia. We've actually published on that one. Cryptosporidium is another one. Some worms, some helminths that appear to be shared somehow between people and chimps. It's a little harder that way because there's a lot of environmental routes of transmission through water, through soil. But recommendations for being in the forest and watching apes, if you can't hold it in, either bring a plastic bag with you and carry it out with you, which, would take a lot of willpower, I would say. But if you just can't do that, dig a really deep hole, because you're right. Gastrointestinal pathogens, viruses, bacteria, and parasites, they seem to be easily able to go back and forth between chimps and humans. In fact, one of the first studies we ever published on this was on bacteria, common E. coli bacteria, where we looked at antibiotic resistance patterns. And we found antibiotic-resistant bacteria in the chimps where the pattern of multiple antibiotic resistance was identical to what we saw in local people. Yeah.
Again, that human-animal bond, that human-animal connection, again, is super deep and super thorough. Would you mind doing this? We are going to just take a quick break, a quick pause. And then when we come back, I want to shift species for a second, because what you've been talking about is absolutely fascinating. And I know we're going to have that level of interest and complexity in the next species we talk about. Will you hold on for just a few brief moments?
You bet.
Excellent. All right. We'll be right back.
It's designerpetsweaters.com. Hand-knitted designer sweaters for your precious pup or cool cat. Beautiful couture patterns for your pets, including custom-knitted formal wear, casual wear, yachting, and even sports-themed. Many designer pet sweaters include feathered tammy hats, top hats, and a lot of sparkle. Each sweater includes leg loops, front paw sleeves, and leash opening. Visit designerpetsweaters.com to order your four-legged fashions today. Your pets will stay warm for the winter and be runway ready. Large or small, we fit them all. designerpetsweaters.com.
Let's talk pets
Let's talk pets
on Pet Life Radio.
Pet Life
PetLifeRadio.com.
Radio.
And we're back. We're speaking with Dr. Tony Goldberg, a veterinary epidemiologist, and like I said, an extremely rigorous and diligent researcher. We've just had a fascinating discussion about reverse zoonoses, anthropognosis in chimps. We've talked about outbreaks, some pretty heartbreaking stories about chimps who have been infected, who have gotten infected and succumbed to diseases that humans carry. And the goal is trying to figure out how those diseases actually made it into that chimp population. But right now, I'd like to just shift species for a second, because Dr. Goldberg, you've studied West Nile virus, primates, ticks, fish, and a host of other species. But I want to talk about a species of great national importance, and that is the bald eagle. My heart goes out to that species because they've been through a lot. I mean, not only have they had to dig themselves kind of out of the brink of extinction, and that's a lot of thanks to the conservation efforts, but, there's been some groundbreaking work by you and your team that a new virus has been discovered in bald eagles, and it's infecting about 1/3 of bald eagles in North America. What is that virus, and how did you and your team discover that?
Well, yeah, bald eagles are a pretty charismatic species. I guess I'm lucky. I get to study things like chimps and bald eagles, the most charismatic megafauna on the planet. But we found a new virus in eagles that no one knew existed, using sort of DNA sequencing-based virus hunting methods, which is one of the things my lab does. The virus is actually a distant relative of human hepatitis C virus, and which is a major cause of hepatitis in people. It's sexually transmitted, and it can be transmitted through IV drug use. And I've very rarely seen eagles use IV drugs, by the way.
Not yet, but anything's possible here on this podcast. Yes, exactly.
That's right. So we found this virus during a study into a mystery disease of bald eagles. We all are aware of Silent Spring, Rachel Carson's famous book, pointing out the effects of DDT and other environmental chemicals on wildlife, particularly birds in her case. These chemicals were thinning the eggshells so much that they weren't successfully hatching their chicks. And bald eagles plummeted. So we're really aware of toxins as a cause of disease and population declines in eagles. But surprisingly, we don't know very much at all about infection. So there is this disease called Wisconsin River Eagle Syndrome. And listening to that name, your listeners will probably recognize that it has a vague name because people really had no idea what was causing it. So it's a syndrome. Mm-hmm. The syndrome involves sort of ataxia, staggering around, vomiting, and sudden death of eagles that were in otherwise pretty good shape. And this was happening around the Wisconsin River here in my state of Wisconsin, which is a beautiful scenic river with a lot of eagles. It's great eagle habitat. So over the decades, the Department of Natural Resources and the National Wildlife Health Center, which is also here in Madison, Wisconsin, was getting eagle submissions from birds that had died of this mystery disease, and they couldn't figure it out. They looked for toxins, they looked for known pathogens like West Nile virus, they looked for kind of environmental and ecological associations, they looked for vitamin deficiencies, nothing was coming up. So they put this on the shelf, and we were talking one day, and I asked them, what's your most frustrating mystery disease? And this was number one. Right. That was at the time that my lab was starting to use these fancy virus hunting methods where you can look for a virus without knowing anything about what you might find. So we did that, and out popped this virus in one of the first birds we tested. It was very surprising. These types of viruses, it's in the viral genus Hepacivirus, were not supposed to infect birds. At least no one had ever found one at the time. And it was really tantalizing because the eagles that were dying of this syndrome had liver disease. And that it looked under the microscope a lot like the liver disease that humans with chronic hepatitis C virus experience. So we were Yeah, so we were really excited. We started popping the champagne corks and saying, yay, we've solved Wisconsin River Eagle syndrome.
That's how epidemiologists celebrate viruses, popping champagne.
We pop champagne, yeah.
Yes,
Well,
okay.
yeah, I mean, that's right. New virus, new bottle of champagne.
Got it.
But we had to recork the champagne bottle because it wasn't that simple. It never is, I guess. We started looking more broadly, and we started finding this virus all over the United States in eagles that had died of other causes.
Interesting.
Eagles have a hard life. The top causes of death for bald eagles in the U.S. are trauma. So they might be foraging at the side of the road on roadkill and get hit by a car. Gunshot wounds, people shoot them. Yeah, electrocution, they'll land on electric wires and get electrocuted. Poisoning, there'll be poison set out for other wildlife, or maybe, poison carcasses on ranch lands, and they'll eat that and die. So they've got a rough life, even though they're our national bird. Right. So we started looking at all these eagles that came into the National Wildlife Health Center here in Madison from all over the United States. And we started finding this virus in eagles as far away as Florida and the state of Washington. So it was, all in all, it infected about a third of the eagles we tested, including ones that had clearly died of reasons other than Wisconsin River Eagle syndrome. Now, what we did find is that eagles from Wisconsin were about 10 times more likely to have this virus than eagles from elsewhere. And eagles from the places in Wisconsin where Wisconsin River Eagle syndrome had been diagnosed were about 14 times more likely to have this virus than eagles from elsewhere. So there was a statistical association, but it was not a simple thing of this virus always is found in a bird that has this syndrome. Wow. So that's kind of where we are. We're left with this conundrum. Does bald eagle hepatovirus, which is what we call the virus, cause Wisconsin River Eagle syndrome? Is it just an incidental finding, or does it interact with other factors to cause the syndrome? And I wish I could tell you the answer, but that's the line of research we're pursuing.
There is no doubt in my mind that you will discover the answer soon. You are a dogged researcher, and that is coming soon.
That's a good one.
Yes. One thing that you said as an aside was that you mentioned that the Wildlife Research Center is near you. Is that true?
That's true. So
you've got the Wildlife Research Center near you, and then you also work, you mentioned, with a human hospital that you said is near the vet school. That's the University of Wisconsin Pediatric Medical School?
Yeah, so I work with the University of Wisconsin Hospitals and Clinics Department of Pediatrics.
Department of Pediatrics, okay.
Yep, with a great collaborator, Jim Gurn, who's a world-renowned pediatrician who studies infectious diseases like rhinovirus C and asthma, with great virologists here. So the world expert on rhinovirus C, that virus that infected the chimps, is my colleague Ann Palmenberg, who's a very well-known virologist here on campus. So this co-location of the vet school, the med school, and the main flagship campus of the University of Wisconsin system is rare. Most of the times, they kind of put the vet school out on a satellite campus with the cows, and the medical school is in a major metropolitan area.
And that's essentially what I'm driving at. I mean, it takes a village to really find and discover these pathogens, and an entire team. And that's one thing that I think you are going to see a lot more of. Well, you've been seeing it for decades, but I think a lot of people are just now getting introduced to it. And that is that concept of One Health, global health, and how we all work as sort of this medical tribe, essentially, where we all work together, whether you're a pediatrician, a physician, a veterinarian, a wildlife researcher, we all work together to help improve the health and wellness of all organisms, not just people or not just animals. You seem to sort of embody that One Health, global health initiative.
Well, thank you. That's very flattering. That is the guiding philosophy behind what a lot of us in this field do. And it works on two ways. You're right, it takes a village. So there's One Health in the sense that all the health professions are really studying the same thing. We just tend to focus on slightly different species. But there's also the idea of One Health being that there's really one concept of health that applies to all species on our planet, and there are no borders among those species. So we can, if we want to understand human health, we can't ignore animal or plant health for that matter. And if we want to understand the health of animals and plants, we have to understand human health. So everything really is interlinked. And it, in very tangible ways, it comes together through these sorts of collaborations. If I didn't have these remarkable collaborators here, if the National Wildlife Health Center, the CDC for wildlife, so to speak. We're not here in Madison, Wisconsin. A lot of these studies would never have gotten done.
Well, this is fantastic. That intersectionality, that how we're all connected, is something that I think we could even highlight when we jump to the bottom, sort of the phylogenetic pyramid or the ecological pyramid. We were talking about bald eagles. Let's jump to someone would call sort of the bottom of that ecological pyramid. And that's a species that is what somebody might describe as a primary producer or primary consumer. And that's freshwater mussels. It appears that the mussels have reached or hit the news recently. They're dying across the United States, and something is killing them. And people may not be sort of casually interested in mussels, besides obviously on their dinner plate. But what is the importance? What did your team discover about the importance of mussels, and essentially why should we care?
Another great question. So, before I answer that directly, I'll just, apologize to your viewers who probably think, who is this guy studying chimps, bald eagles, and freshwater mussels?
Oh, and it said that's just the start. It's lions, tigers, and bears. But seriously, please explain.
So, you know the adage from James Herriot, all creatures great and small. I think that as a veterinarian, we are tasked with the health of all creatures. So the unifying theme here and why mussels are so important is that there are diseases of animals that don't infect people, but affect people. So we are not separate from nature. We are part of ecosystems, and the health of those ecosystems determines our own health and well-being. So veterinarians have the luxury of being able to focus on systems that are similar to humans, like chimpanzees, and systems that are really far away phylogenetically from humans, like bivalves. And yet, each of those species has a unique place in ecosystems and in ecosystem services that benefit people and benefit the world. So the key link is ecosystem services. Freshwater mussels are not the kind of mussels that you eat. Unless you were a Native American living a long time ago, the mussels people get at restaurants are marine mussels. These freshwater mussels live in rivers and lakes, and they are the most important species that filter water.
Interesting.
So when you get cloudy water from a rain or something like that, mussels are voracious eaters of small particles in water, and they will filter those particles in, suck out the nutrients, and deposit the remaining stuff on the riverbed. So you can do an experiment where you take one of these mussels and you put it in a tank of cloudy water, and you have an empty tank of cloudy water next to it. And in less than a minute, the tank with the mussel will be clear.
Unreal. That's that's a fast filter. That's faster than any man-made filter that I know of.
Oh, yeah. So that's the concept of ecosystem services. The idea is if we lose mussels, can you imagine having to build machines to clear our entire rivers? We're getting this for free right now. From these animals that have evolved in these systems. And that's why in places like the Appalachian Mountains, where I'm doing most of this work, the rivers are clear and beautiful. I was just there a couple of weeks ago snorkeling in the Clinch River on the border of Virginia and Tennessee with my colleague Jordan Richard at the U.S. Fish and Wildlife Service. And we were watching mussels and kind of walking along the riverbed to assess the situation. And like he'd been telling me, they're dying. We were finding unusually large numbers of fresh dead mussels on just a casual walk across one of these shoals on the riverbed. And if you kind of multiply that by the number of days in the year, and it turns out we are in peril of losing a lot of these keystone species that filter our water. It's happening in the east of the United States. It's happening in the Pacific Northwest. It's happening in Europe. So this is an unfortunate example of this extinction crisis people have been talking about. Animals are in trouble from global forces, ultimate drivers like climate change and development, agriculture and human population expansion, and they're dying. And if we lose them, the ecosystems that they maintain will never be the same. If we were to magically get rid of the mussels on the Clinch River in Tennessee and Virginia, in not too long, you'd walk down to that river and you wouldn't recognize it. It would be muddy and silty. It would have algae on it. And those changes would cascade all the way up to the forests on the mountainsides nearby. It would just never be the same. So this just raised huge alarm bells for me when I first heard about it, both because of my love for nature and because of my oath as a veterinarian to protect animal health. So I joined a team of scientists with the federal government and universities, and we kind of jokingly call ourselves the Muscle Delta Strike Force.
That is the most powerful name I've ever heard.
So we're diverse. We bring our individual talents. So we have a river biologists, pathologists, metabolomics or physiology specialists, muscle biologists, me sort of the infectious disease epidemiologist, bacteriologist and pathologist, and toxicologist. And we're desperately trying to figure out the proximate causes why these muscles are dying. The ultimate causes are probably really huge things that we can't change in time, like climate change. Right. But we're focusing on what's actually killing these muscles because we got to try to stop it. If we lose them, they're never coming back. So while we work on the world's bigger problems, we're focusing on what we can do right now.
Well, that's really fantastic because, when you talk about sort of how all of you together are working for one common cause, that's something that really speaks to me. I actually wrote an article specifically about algae blooms and cyanobacteria and how we truly have not only just a connection, that human-animal bond, a connection to our pets, but both cyanobacteria and that toxic blue-green algae can not only affect and kill pets, it can kill wildlife, it can kill humans. And the worst part about it is that, particularly in veterinary medicine, there is no antidote. There's no known treatment for that. And so talking about climate change and how that influences all of us is something that I think needs to be explored further. I wanted to get to how you basically start that virus hunting expedition. But what I want to say, and this is going to be a little bit disappointing for our viewers and for our listeners, is that we've run out of time. So what I want to do is, if you don't mind, I'd love to, at some point in the future, could we do a round two? Because you're so fascinating. We've only talked about 10% of the species that you've actually studied. And so your breadth of research and depth of research is really, really fascinating stuff. Would you ever consider coming back?
Oh, you bet, Courtney. No, I think one of the pleasures of talking with you and getting the invitation is that another team that I've come to respect quite a bit is the profession of veterinary medicine. And we are bound by a common cause, and you are clearly a champion of that cause, and we need to work together to get the message out.
I really appreciate that. Thank you so much for saying that. I really would like the listeners to know, where can they learn more about you? Where can they see more of your research? And if they're interested, how could they help? How could they support what you're doing?
Great questions again. So I've got a website at the University of Wisconsin School of Veterinary Medicine. I've got a faculty page there and a link to other websites and popular press. So
do you know off the top of your head what that website is?
I do. It's a little bit complicated, but I can give it to you right now. It is vetmed, vetmed.wisc.edu/Goldberg Lab.
Okay. www.vetmed/wisc.edu/Goldberg Lab. Okay, fantastic. Yep. That's great. And of course, when in doubt, if that's too long for some of you listening, of course, just Google Dr. Tony Goldberg and you'll have too many hits to count. You don't even need to go to the second page because nobody goes to the second page on Google. So you can just stay on that first page and there's plenty there for you.
Yeah, and if you want to see something funny, and we can talk about this next time, Google Tony Goldberg nose tick.
Oh, yes, you are famous for that. All right, that is, I have some research to do on the CDHR3 allele, and everybody else, you can, your homework for the weekend and for the rest of the week is Dr. Tony Goldberg nose tick. Awesome. Well, Dr. Goldberg, thank you again for joining me today. It's been a fascinating conversation, and I'm going to hold you to that promise to do round two.
You're welcome, Courtney.
All right, fantastic. Well, there you have it, folks. That was the illustrious guest, Dr. Tony Goldberg, talking about pathogens and infectious disease. Like I mentioned to you, a real megastar in the world of infectious disease and just in the trenches, essentially in the rivers, keeping us safer. And all of this stuff happens in the background. We don't know about it. Some of us don't ever hear about it. But these are the people like Dr. Goldberg helping to keep us safer. He obviously grew up in the best state in the country, which is Connecticut, and no bias there. But he essentially grew up like I did, out in the woods, studying, lifting up rocks, looking at wildlife, and that led him to get his PhD. And then that human-animal bond, with that connection between chimps and the AIDS virus, led him to vet school. And since then, he's been continually researching infectious disease, from the outbreak in chimps to bald eagles to even mussels. And he really highlights the One Health concept, that concept that health applies to all species on our planet, and it takes all of us to maximize that health. So he's surrounded by a team of professionals from the Wildlife Research Center to the Medical Pediatric Center at University of Wisconsin-Madison. So it really is a team approach. And so we just want to celebrate Dr. Goldberg today. And thank you all for listening to Anything Possible. We will have more exciting guests on the next episode. And just keep in mind, there's nothing stronger than the human-animal bond.
Let's Talk Pets, every week on demand, only on PetLifeRadio.com.